We're going to take a look at simplifying radicals. And once you get the hang of it, I want you to go to IXL in Algebra 1, section EE.1 to do some practice. So let's look at some examples of radicals of just integers that we need to simplify. So for instance, if we have the square root of 24, you want to make a factor tree starting with numbers that give you 24 when you multiply. So for example, 4 times 6 gives us 24. And 2 times 2 are factors of 4, and 2 times 3 are factors of 6. So we have factored all the way down to our prime numbers. And notice we have a square root, so we need to have a pair of numbers in order to take one out. So we have a pair of 2's, we're going to take out 2, and what's left over are the 2 that are right beside it that did not have a pair. So 2 times 3 would give us back 6. So that's it for simplifying the square root of 24. Let's look at another one. So what if we have the square root of 50? 50 comes from 5 times 10, and 10 comes from 5 times 2. So we end up with a pair of 5's, so we could take out a 5 because of that pair of 5's, and we have a 2 left over. Now, you might have thought, well, what about 50 coming from 2 times 25? What if I thought about it that way? Well, let's look at it. 2 times 25 does give us 50, and then 25 is 5 times 5. And then you still have that same pair of 5's that ends up in your factor tree, so you would still take out the 5 and have a square root of 2 left over. So it does not matter which factors you start with, as long as they are correct factors of the number, you would end up with the same simplified form. Let's look at another example. What if we have the square root of 8? So 8 comes from 2 times 4. 4 comes from 2 times 2. So I have a pair of 2's. I can take one out. And then the square root of 2 is left over. So the square root of 8 is equal to 2 square root 2 when I simplify. Now let's look at another one. What if I have the square root of 27? So 27 comes from 3 times 9, and 9 comes from 3 times 3. So I have a pair of 3's, so I can take one out because of that pair, and then I have this 3 left over. So the square root of 27 when simplified is equivalent to 3 root 3. Let's look at the square root of 72. So the square root of 72, 72 comes from 8 times 9. 8 comes from 2 times 4. 9 comes from 3 times 3. And 4 could be broken down to 2 times 2. So then we have a pair of 3's and a pair of 2's. We could take out a 2 and a 3, so they get multiplied together and put in the front of our radical. And then you have this other little 2 left over. So 2 times 3 would be 6. So it simplifies to be 6 times the square root of 2, or 6 root 2. Let's look at another example. What if we have the square root of 36? So 36 comes from 6 times 6. 6 comes from 2 times 3. And the other 6 comes from 2 times 3. And then notice we have a pair of 2's and a pair of 3's. But then nothing would be left over. So notice we could take out a 2 and a 3, which is equal to 6. But then nothing is left over, so that's fine. And you might have already known that the square root of 36 is 6. Notice we also have a pair of 6's right there, so you could have stopped and taken out a 6 because you have that pair of 6's. But any way you think about it, it just comes out evenly as 6. So then that's it for that one. All right, let's just do one more. Let me grab a different color. The square root of 12. So 12 comes from 3 times 4, and 4 comes from 2 times 2. So we could take out a 2, and then the square root of 3 would be left over. Okay, so feel free to re-watch this video if you need to, but hopefully that will help you get started, again, on IXL Algebra 1, Section E,